So for the earlier part of the quarter, we have been describing how we can use math to study biological phenomena. But today, we are going to do it the other way, where we use biologically inspired algorithms to come up with mathematical models. The challenge or problem that we are going to do this example on would be the binary classification task. So for those of you who have not taken statistics or machine learning before, the goal of this task is to find the relationship between an input vector, and I'm going to give a detailed example after this, between input vector and a binary output. Say, by binary, yes or no, 0 or 1, and so on. Okay, here's an example. Suppose you have this data set. So your friend comes over and wants some help with time management. He tells you the hours that he spends exercising each week, and the hours that he spends socializing. And then he asks you to predict if for that week he would be able to finish his 342 homework. Let's see. Finish 342 homework. 342 homework. And so we notice that xe and xs, they're both scalars, and y, the thing that you're supposed to predict, is binary, just 0 or 1. Okay, so this problem is divided into two phases. Training phase, whereby your friend gives you, your friend being a very meticulous student, has recorded over the past few weeks his time spent and whether or not he finishes his homework. For example, in the first week he might exercise for 4 hours and socialize for 4 hours and still has enough time to finish his 342 homework, y equals 1. But maybe next week he's over socializes and so he can't finish his 342 homework, and so on. So in the training phase, you are given the y labels, but later on your friend asks you, well, in subsequent weeks I am going to spend this much time on each activity. Can you tell me whether or not I would be able to finish my homework? So the binary classification task is then challenge. Predict the missing y's, given that you already know the training phase labels, given training data. Okay, so there are many ways to do this, and if you want to know the full spectrum, you can take a machine learning class. But the general idea is, the intuition is, somehow you need a compact summarization of the training data and apply it to the test data. So need a model or summary or generalization over training data, then use it to apply it to test data, to test data's x values to predict the missing y's. Okay, let's explore this intuition further. I'm going to plot the training data graphically so we can see what's going on. Suppose the axes are XE and XS, and let's see, 4, 10. And then I'm going to plot each data point, each row here is one dot. This row would be another dot. And I'm going to use these colors. Red means the Y label is 0, green means the Y label is 1, and then let's use purple means don't know. So 441, which means I will have to use green color. 441. In that week, the student manages to finish the 342 homework. 410 0. So too much time socializing, can't finish homework. And then for the testing phase, 10-4 and 10-10, we don't know. Whoop, whoop. Okay, so that's our data. How do we predict the true colors of the purples? Well, in this class, we will just adopt this simple idea. What if our model, again, a summary over the training data, is just a line? And then we say on one side of the line, we'd call these all reds. On the other side of the lines, we would call these all greens. Okay, if so, then what would be a good line model? Example of line model. So an intuition that makes sense for this problem would be maybe the person would be able to finish the homework if XE plus XS is less than some amount. And I'm going to choose the value 10 just because it would be able to separate our red and green dots nicely. So again, the intuition is total non-study time less than 10. Okay, how does this look like? Well, okay, I'm going to plot the line over here. Okay, so our decision boundary, XE plus XS less than 10, what does it look like? If we draw it here, it would look like this. It would cut across XS10 and XE10, and we say that YE is 1, and Y equals 1. That means we would choose green if it's to the left of this line, and then we would choose red for anything on the other side of the line, which means with this model we would have predicted reds to the test data. So 0, 0. All right. Okay, so what have we done here? We have summarized train data with this line model, and then we use line model to predict the missing labels.